Hello friends, how are you all? Hope all are doing fine. First and foremost, let me introduce myself. My name is Navin. I am student of TTWREIS Boys Narsapur. As guys, before going to start my session, I would like to speak something about on my topic. So let's start the session. So let me show one picture. What you observe in this picture? What you notice in this picture, guys? Yes guys, you are correct. The picture says about a relationship, a bonding in between human beings. For example, the bond in between father and mother, the bond in between brother and sister, the bond in between wife and husband. Hope you all understood, guys, which topic I am going to teach right now. Yes, that is chemical bonding. Just now we seen the bond in between human beings like this in our chemistry, except zero group elements. Remaining all our elements, they participate in bond chemically. That's why we call as a chemical bond, guys. Yes, so let's move on. First we have to know what is chemical bond. Yes, the force of attraction between two molecules, between two atoms, between two ions that keeps together, that holds together, it's now as a chemical bond, guys. Yes, so let me give one example. If the pen is like this, is due to a chemical bond, guys. If the food we eat, the dress we wear is due to a chemical bond, guys. Everything in the universe is as a result of chemical bond, guys. If there is no chemical bond, what could happen? If there is no chemical bond, there is no force of attraction, guys. If there is no force of attraction, there is no formation of compound, guys. Yes, let's move on, guys. So let me raise a few questions for you guys. My first question is here, why do atoms participate in a chemical bond? Yes guys, you are correct. The atoms participate in chemical bond to get the stability. Yes. My next question is here, how do the atoms get stability? Yes guys, yes. The atoms which has 8 electrons in their valence shell, then the atoms is said to be more stable. So my third question is here, why do atoms need 8 electrons to be stable? Yes guys, as we all know, in periodic table, zero group elements are more stable and they have 8 electrons in their valence shell except helium. So like this, to attain a similar electronic configuration of zero group elements, the remaining elements need 8 electrons to get the stability. That's why they need 8 electrons, guys. So let's move on. The classification of chemical bond. Guys, so let me take one example. If the pen is like this, when I am trying to pull my refill out, but it is not coming out because of it is very stable here. So that's like this each and every atom to participate in chemical bond to get 8 electrons in the outermost shell and to be stable. Yes guys, let's move on. The classification of chemical bond. Generally, the classification of chemical bond are two types. One is ionic bond and another one is covalent bond. So the bond formed in between metal and non-metal due to complete transfer of electrons is called ionic bond, guys. In case of covalent bond, the bond formed chemically in between two non-metal atoms by mutually sharing of electron, guys, is called covalent bond. So to form ionic bond, their electronegativity must be greater than 1.9. To form covalent bond, their electronegativity must be similar, guys. Let's see some examples of ionic bond and covalent bond. First we see example of ionic bond, guys. NaCl, the sodium chloride, it also known as a table salt. It also known as a table salt, guys. See here, guys, the sodium atom. Sodium belongs to a first group element, so it has a one valence electron. In case of chlorine belongs to a 17th group element, so it has a 7 valence electron, guys. So to get the stability, how many electrons to be need? 8 electrons to be need to get the stability, guys. But in case of sodium, one electron is more to get the stability. So the sodium transfer one electron. The sodium transfer one electron to chlorine, guys. So chlorine is need one electron. chlorine, it needs 1 electron to get the stability. So the sodium transfer 1 electron to chlorine, and the sodium forms unipositive ion, and it gets 8 electrons in the outermost shell, guys. In case of chlorine, the chlorine forms uninegative ion, and it also get the 8 electrons in their outermost shell, guys. So they now by the transfer of electrons in ionic bond, they get the stability, guys. In case of covalent bond, first we see example of diatomic chlorine. So we have 2 chlorine atoms, guys. The chlorine belongs to 17th group element, so it has 7 valence electrons in the outermost shell. So it needs 1 electrons, and another chlorine also needs 1 electrons to get the stability. So they transfer, they mutually share their electrons. And they form 8 electrons in the outermost shell, guys. See here, guys, 1, 2, 3, 4, 5, 6, 7, 8. These chlorine atoms get 8 electrons, so it gets stable. And another chlorine atoms also get 8. 1, 2, 3, 4, 5, 6, 7, 8. It also get stable, guys. So in case of O2, see here, guys, O2 belongs to 16th group element, so it has a 6 valence electron on each atom. So the oxygen atom has a 6 valence electron, and another atom also 6 valence electrons. So they share their electrons. And they form 8 electrons in their valence shell, and they form covalent bond, guys. See here, in case of nitrogen belongs to a 15th group element, so it has a 5 valence electron, guys. So it needs 3 electrons. They share their electrons to get the stability. See here, guys, it attains 8 electrons, and it also get 8 electrons to be stable. So they are stable, guys. See here, the chlorine need 1 electron. To get the stability. So they form a single covalent bond. In case of oxygen, the 16th group element, so it needs 2 valence electrons, and they form double covalent bond. In case of nitrogen, the nitrogen molecule, it needs it belongs to a 15th group elements, so it has 5 valence electrons. To attain the stability, more 3 electrons is needed. So the 3 electrons needed, so it forms a triple covalent bond, guys. Yes, these shared electrons is called as a bonded electrons, guys. Bonded electron or bond pair. Yes, this non-sharing electron is called non-bonded electron, guys. Non-bonded electron or lone pair. Yes, guys, let's move on. So the formal charge. What is formal charge? The formal charge tells about the charge has on which atom, the charge present on which atom in a compound, guys. See here, let me tell one example. Here, cyanide ion. Cyanide ion is a carbon, belongs to a 14th group element, so it has a 4 valence electrons. In case of nitrogen belongs to a 15th group element, so it has a 5 valence electrons. Here negative charge indicates is a gaining of 1 electron, guys. So the 4 valence electron of carbon and 5 valence electron of nitrogen, and 1 electron gained by negative charge. So we have 10 valence electrons, guys. We need paired electron, guys. 2 electrons is equals to 1 pair. 4 electrons is equals to 2 pairs. So we have 10 electrons. So how many pairs? 5 pairs electrons are there, guys. By using 5 pair electrons, how to draw the structure? Let's see, guys. Here carbon. So we have 5 paired electrons. Among them, 1 pair electrons are used. So remaining 4 is present, guys. Remaining 4 is present. So see here, 1, 2, 3, 1, 2, 3, 4, 5. 5 pair. Is it correct structure? No, guys. Why? Because why the atoms are participating in chemical bond? To get the 8 electrons, to get the stable. That's why they are participating in chemical bond. But what here Here carbon has only 4 valence electron, guys. 4 valence electrons. How many electrons are present? So 1, 2, 3, 4, 5. So 5 valence electrons is not stable, guys. We need to get the stable, we need 8 electrons. So what we will do? So it forms a triple bond. See, guys, 1, 2, 3, 4. Now each atom gets stable, guys. See here how to calculate the formal charge. I'm taking examples the cyanide ion, guys. F is equals to x minus y, where x is equals to valence electron in free state and y equals to number of valence electron in Lewis structure. See here, guys, the x is equal to valence electron in free state. I am first take the carbon as a carbon. Take the carbon, guys. The carbon has a valence electron 4. 4 valence electrons are present, guys. And how many number of electrons in Lewis structure? See, guys, how many number of valence electron in Lewis structure? 1, 2, 3, 4 and 5. So 5 valence electron of carbon in Lewis structure, guys. So 4 minus 5 is equals to minus 1. So the charge is present on carbon. In the compound, the negative charge is present on carbon. See here, guys, of nitrogen. So nitrogen belongs to 15th group element, so it has a 5 valence electron in free state and number of valence electron in Lewis structure 1, 2, 3, 4, 5. Is a 5 minus 5 is equals to 0. So there is no charge present on this, guys. So the negative charge is present on carbon. This is about nothing about formal charge, guys. Let's move on. Hybridization. Yes, guys, so many people get confused. They don't know how to draw the structure of and they don't know how to find the hybridization shape, angle of any compound. To rid of their doubts, I will explain with a simple trick, guys, based on the steric number, how to find the hybridization shape and angle of any compound, guys, whatever it may be. How to find the hybridization shape, angle of any compound based on only steric number, guys. So how to find the steric number? Please remember this table, guys. You can find you will easy to find hybridization shape, angle of any compound. See here, guys, I am going to take example is a beryllium fluoride. First step we have to do is first we have to identify the central atom. Yes, central atom is a beryllium. So beryllium belongs to second group element. So it has a 2 valence electron, guys. 2 valence electron. Next step we have to do to find the steric number. How to find the steric number? Steric number is nothing but the sum of sigma bond and lone pair. So how to find the sigma bond? Yes, guys, our question is how to find the sigma bond. Sigma bond is nothing but how many atoms are attached to a central atom. That is nothing about sigma bond. So how to how many sigma bonds are present, guys? Here beryllium fluoride is a beryllium act as a central atom. So it has a 2 valence electron. Then how to find the sigma bond? The number of atoms attached to a central atom is 2, guys. The 2 fluorine atoms attached to a central atom. So sigma bond is equals to 2. So easy, guys. So how to find the lone pair? The valence electron of central atom minus number of sigma bonds. Yes, guys. See here, to find the lone pair here, the valence electron of beryllium is 2 and to find the steric number is number of sigma bond plus lone pair. This step is clear, guys. So how to find the number of sigma bond? Number of atoms attached to a central atom. Yes, here the 2 atoms are attached. So the sigma bond equals to 2. Here 2 fluorine atoms are attached, guys. So sigma bond equals to 2. So how many lone pair, guys? Here see, guys, valence electron of beryllium is 2 and how many sigma bonds? 2 minus 2 equals to 0. So it is a 0. We get 0 lone pair, guys. So steric number equals to 2 plus 0 equals to 3. So 3, we get a steric number 3. 3 means what, guys? Hybridization sp2 and shape is trigonal planar and angle is 180 degrees. No, guys, sir, excuse me, please. Here the steric number 2 plus 0 equals to 2. We get the 2 steric number. So based on the steric number, the steric number 2 is sp hybridization and shape is linear, angle is 180 degrees. So easy, guys. So let's move on another example. The example is phosphorus trichloride. So first identify the central atom. So here phosphorus act as a central atom. And how many valence electrons of phosphorus? So phosphorus belongs to 15th group element. So it has 5 valence electrons. So first step is over, guys. So next step, what we do to find the steric number? How to find the steric number? So number of sigma bond plus lone pair. How to find the sigma bonds? Number of atoms attached to a central atom. Here here guys, 3 chlorine atoms is attached to a central atom. So how many sigma bonds? 3 sigma bonds are present. 3 sigma bonds are present. Now how many lone pairs, guys? To find the lone pairs, the valence electron of phosphorus is 5 and number of sigma bond is 3. We get 2 guys. So 5 minus 3 equals to 2. 2 electrons. 2 electrons means how many pairs? 1 pair. So 2 electron means 1 pair, guys. 1 pair electron. 1 pair electron. So the lone pair is 1. Lone pair is 1. Yes, guys. So steric number is equals to sigma bond plus lone pair. Here sigma bond is 3 and lone pair is 1. Steric number is 4. So based on the steric number 4, so what is, guys? sp3 hybridization and shape is tetrahedral and angle is 109 degrees 5 minutes. 109 degrees 5 minutes. So easy, guys. You can find every compound like this same way, guys. So see next example. H3O plus. First we identify the central atom, oxygen. Here oxygen is act as a central atom. The valence electron of oxygen is 6. So here positive charge indicates is subtract one electron, guys. Here if he indicates the plus 2 charge, we can subtract minus 2, guys. Yes. So here indicates plus 1 charge. So we can subtract minus 1 from valence electron of oxygen. So 6 minus 1 equals to 5. So how many sigma bonds are there, guys? How to find how many sigma bonds? The number of atoms attached to a central atom. So how many atoms are attached to a central atom? The central atom is oxygen. How many atoms are attached? Here 3 hydrogens is attached. So sigma bond is 3. Sigma bond is 3, guys. So how many lone pairs are there? So valence electron 5 minus 3 equals to 2. So 2 means 1 pair. So lone pair equals to 1, guys. Lone pair equals to 1. To find the steric number, 3 sigma number of sigma bond plus lone pair. 3 plus 1 equals to 4. The steric number, we get steric number 4 means what, guys? Steric number 4 means we get sp3 hybridization and shape is tetrahedral and angle is 109 degrees 5 minutes. So let's move another example. That is xenon tetrafluoride. First we same way we do, guys. The valence electron of xenon is 8 and the number of sigma bond is how many atoms are attached to a central atom is 4 and lone pair equals to 2. 8 minus 4 equals to 4, guys. 4 electrons are present. How many pairs? 2 pairs. So lone pair equals to 2. Lone pair equals to 2. So steric number equals to number of sigma bonds plus lone pair. Here 4 plus 2 equals to 6. 4 plus 2 equals to 6. So we get the steric number 6. It means what, guys? Steric number 6. We sp3d2 octahedral and angle 90 degrees. And angle 90 degrees. This is very easy way to find, guys. This is very important and you can find like same way of any compound, guys. And finally this is all about our today topic. And finally I would thankful to my legendary principal sir and teachers and my mentor and special thanks to the secretary sir and OHD Rangareddy sir and RC sir and other officials of Gurukulam to giving me such a grateful opportunity to teach on TSAT, and I feel it's my honor. Thank you once again.